Differentiating now squares of Greek functions is what you are going to see in this lesson. In the previous lesson, we have seen how to differentiate cos and sine from first principles. Now, we are going to see how we differentiate their squares from first principles. Now, the idea here, I'm going to handle this, you'll handle this too. The idea here is we are going to use a difference of the squares, and we know the factor formula states this. And that in radians, sine of a small angle approximates that small angle, and cos of a small angle approximates a 1. We are going to see where to apply that. What we say, you can use a function equation or use small changes. Here I'm using small changes. So let y be sine x squared, sine squared x, and delta y be small changes in x and y respectively. That means that we receive a small change in y and then x, because x is valued with y. So if I receive a small change in y, means that also I'm going to receive a small change in x, like that. Now from here, we make delta y the subject. So my delta y is going to be, now I take this side, sine squared x plus delta x, then minus y. But you know y is this, so plus delta x, then minus y, which is sine squared x. But remember now, it's the difference of the squares. This is the idea. If you have a squared and b squared, you apply it here as u and then c. So I get this, I subtract this and this, then also I add them. So from here, 9 delta y is going to be, now you open brackets, you add this and this, so you get sine x plus delta x, then plus sine x. This is our x, this is our x, our b. You subtract them, then you follow the signs here. I subtract them, then I add them, or you can add and then subtract them too. But now, let me follow the idea here. You subtract them, then you add them. So then I add these two. Then sine of x plus delta x, then plus sine x. The whole of this in brackets. So here we have applied the difference of two squares. Now we are subtracting, this is a, this is our b. Now we bring in this idea, when you are subtracting, there we use the factor formula. So from here, now my delta y will be, we say, the whole of this is going to be now 2. We say if you are subtracting, you subtract also these two angles, then sine. So 2, then I subtract these two angles. So I have now sine. When I get x, you look here. When I get my x plus delta x minus this x, I subtract with the 2. Then I divide them with the 2. So this and this is going to cancel. I will remain with only delta x over 2. Then cos, you add those two angles. If I add now x plus delta x plus x over 2, I'll be adding 2x over the whole of this. So this will give me 2x plus delta x, the whole over 2. So we have finished the first. Then we come to the second, we also apply the factor formula for rate. So you see, I'm subtracting. Now this one, I'm adding. So when we are adding these two, we get a arm. Now for sine, it's add. Whenever you are adding, you get those two angles, the sum of those two angles. Whenever you are subtracting, on the side, you get the difference of those two angles. So when I add this and this, I have now sine this angle plus this, I get x plus x, which is 2x. Remember, I have delta x, so it will be 2x plus delta x. Don't forget to divide with the 2. Then cos of this arm minus this arm. When you get x plus delta x minus x, the x is going to cancel. Remain with delta x over 2, the whole in brackets. So from there, we can easily simplify and you see that this one here, we are going to be having delta y equal to 2. Now this is going to give us sine delta x over 2. Then we can reduce this to here. So you have now cos of this divided here, we get x plus this divided here, we get delta x over 2. This 2 is dividing this and is also dividing this. That's why we divide here, we get x, we divide here, we get this. Then times 2, then here we get sine x plus delta x over 2, and then here remain with our cos delta x over 2. Now you start this 2, and this they are going to multiply. So from there, and then we apply this idea. So in radians, okay, maybe we first multiply n. So in radians, comma, when delta x is so small, this means it's very small that it's almost 0, it's tending to 0. We say that now our sine, now the small angle is delta x, but remember we are also dividing it with the 2, so it becomes very, very small. Then the cos of x, delta x divided by 2 will approximate 1. Something small, and then when you divide it by 2, you make it more smaller. So from here now, I'm going to be having delta y equaling to this 2 and this 2. Okay, I'll be having 2 times, now this one in radians is going to approximate to delta x over 2, like this. Then remember this is big, because this angle is big plus something small, we have something big. So there is no change there. Then times 2. Then this is also a big angle over 2. Then times, we say this one approximates 1, like that. So instead of now, this times this 2, we get our, okay, this 2 cancels with this. So I have delta y equaling to delta x times this 2 comes here to get 2 cos this one times this to get this. So this 2 comes there. So you divide by delta x. So by delta x this side, by delta x this side. Remember, the whole of that is a product, so you can use a dividing. So you get delta y, delta x equaling to now cos x plus delta x over 2, then sine delta x over 2. So here we say in radian as delta x tends to 0, then the limit as delta x tends to 0 will be equal to a full derivative. So we introduce it both sides. So introduce the limit as delta x tends to 0 at this side. We also introduce it at this side. So we have the limit as delta x tends to 0 into now. We are introducing this side and also this side. We have 2 cos x, then sine over 2. So we say the whole of this is going to be delta y, delta x equaling 2. Now this means that where there's delta x, we put a 0. So you have 2 now cos of x plus 0 over 2. Then sine of x plus 0 over 2. Where there is delta x, we are putting a 0. Okay, so this will be our dx, but our y was sin squared x. Sin squared x will be equal to now 2 cos, this will be now x, cos this will be 0. Then sin x, and this one you can also write it as sin the double angle sign. This is the double angle sign. We can leave it there. Because now, whenever I differentiate this, we get this. You can also see that you can use also the product rule. I mean the chain rule. Lower the power, you get 2. Reduce the power by 1, maintain sin x. Differentiate sin x, you get cos x. So, as simple as that. So that's it, members. I wish you well. And try now these 2.